n slits, right? So you're adding more waves. At that point, you're getting more waves there. So the amplitude, instead of being at the constructive interference points, instead of being 2a, which will be for 2 waves, the amplitude with n waves is going to be na for constructive interference. So that makes sense. But what is not clear at all is why this is narrow. The fringes became so narrow that when you use the diffraction grating with the lamp that I put here, you could tell the light of the lamp and then very narrow lines next to it. Instead of something softly becoming brighter and then less, it was very sharp. Okay, so that's what I'm not going to spend a lot of time, but I did spell it out in the notes, so I would encourage you to take a look at it later when the notes are posted. But the basic idea is, if you think about the phasors, then you can understand it very quickly. Because suppose that point P is constructive interference, then you have all your phasors, right? That means the angles, the phases of all the waves that arrive at this point, right, are pointing in the same direction. That's the idea with phasor, right? That the angle, the little vector points in the direction of the phase of the wave that arrives there. So this is the phasor for this wave, and the next phasor is the phase for this wave, and so on. So they're all neatly aligned. So they become some very large amplitude, which is n times the amplitude of one of them, right? But look what happens when you move a little bit away from P. You have the phasors are now not aligned. There is an angle, a difference of phase between them. That would be this little angle here, and this little angle is the difference in phase between 2 and 3, and between 3 and 4 there's a little angle, and so on. So the phasor now starts to move around, and after you added n, clearly your amplitude, the resultant amplitude of the wave is not going to be Na. Quickly it's going to become very small. So it just takes a little bit of moving away from point P, a little bit of difference in phase between 2 slits to turn the whole thing, to make the waves actually interfere in getting close to being destructive interference very quickly. This is not the case with 2 slits, because this is when they're aligned, so they have the same difference in phase, or the difference in phase is 2 pi. And if you move the same distance below to Q, then sure, one of the phases has changed a little bit, and the difference between them is the same as before. But when you add this vector with this vector, the resulting vector has a magnitude that is pretty close to being this one. It doesn't decay as quickly as with this one. I'm thinking about it, I thought of an analogy with why is it so hard to work in groups, you know. The difficulty grows very quickly with the number of people involved in the group, so I thought of that analogy and wrote it there too, if you want to read it.